I'm delighted to introduce Rob Cooke, who works for Natural England on environmental policy. He's been interested in polypodiums for over 30 years, and he's been the BSBI's expert on polypodiums, referee, for the last 20 years. And am I right in thinking, or am I putting my foot in it, Rob, that you're the president of the BPS, the British Pteridological Society, right now?
Almost. I will be in April. President-elect at the moment.
Okay, right. I almost got it right. Okay, well, if you'd like to share your screen and power up your PowerPoint, that'd be brilliant.
Okay. Thank you, Jim, and thank you for the invitation to speak at this workshop. I've done plenty of talks online before. I'm not sure I've ever done something called a workshop online before. I usually associate that with microscopes and stuff, so you're not going to get microscopes this time. Okay, let me just get my screen up. So Polypodium in the British Isles, title as it says. The photos I'm using are either mine or those by the late Ken Truen, some of you may have come across, unless otherwise credited. Let me just go through it then. There are three species in the UK. If I'm teaching you to suck eggs, then apologies and bear with me. Polypodium vulgare, which is, I was going to say perhaps the most common, it's certainly as abundant as interjectum, is a tetraploid and is a calcifuge, so acidic conditions. And then Polypodium cambricum on the right of that slide is a calcicole and is a diploid. And Polypodium interjectum is a hexaploid, which has arisen through hybridization between vulgare and cambricum. And hence it is really variable. So the photo you can see, which runs from vulgare on the left through to interjectum through to cambricum, sort of is the typical frond outline which you will read in textbooks. So fairly parallel sided in vulgare, sort of fatter towards the middle in interjectum, and then very broad with the bottom pinnules pointed backwards on cambricum. But size doesn't matter. They can be really variable in size depending on growing conditions, and interjectum especially can be huge. So 3 species, different levels of ploidy. And for completeness, in Europe there is a 4th species, although some authors don't give it full specific rank, Polypodium macronesicum, which is very similar to Polypodium cambricum in appearance. I haven't got a photo. There are 2 subspecies of macronesicum. Subspecies macronesicum, which occurs in the Madeira and Canary Islands, and Azoricum, which is found in the Azores, and I think just a single record from southern Spain. Have a look at that paper if you want to find out more. Rums et al. In Botanical Journal of Linnean Society talks about it, but as I say, they are very similar in appearance to Polypodium cambricum. The differences are very fine and microscopic, and I'm not intending to talk more about those 2 species this afternoon. These next 3 maps I've just grabbed screenshots from the atlases, the online atlases, just to give you a sense of the distribution. And this one, Polypodium vulgare, fairly ubiquitous. I would imagine most of those empty spaces are just under recording. So I'd certainly expect to find it all over Ireland and in a lot of the Midlands where it's not there. So ubiquitous, really. And Polypodium interjectum, much the same. Perhaps less common on the really areas of real acidity in terms of substrates, but really very abundant. And again, I would think a lot of those empty spaces are simply a result of under-recording. But Polypodium cambricum is much less common. Jim, there are questions. I can see a question and something in the chat. Are you collecting these up for later?
Yes, I will.
Okay.
Yeah.
Right.
Don't worry. We'll put all the questions to you after your talk.
Okay. So I don't need to stop. Okay.
Yeah,
so Polypodium cambricum then, very much a southwesterly distribution, and also it is limited by its habitat, which is limestone, basically. So it is a Mediterranean species. So if when you were on your summer holes in the Mediterranean and you saw polypodiums growing, almost certainly it would have been Polypodium cambricum. And because it's a Mediterranean species, it's adapted to Mediterranean weather, which means the fronds flush in the winter. So they die off in the summer. And I've got Polypodium cambricum growing in my garden, and it's looking at its best about now. So it is a species which flushes late in the year, very late, and is green all winter, and then dries off and dies back in the summer. In the UK, as I said, it grows on limestone. Interestingly, in the New Forest, there is a population of epiphytic Polypodium cambricum on the big old trees there. And I do wonder to what extent the distribution we have in the south and the west is something of a relic distribution, and actually it would have been more common as an epiphyte on calcareous surfaces. It is reasonably common in South Wales on that Carboniferous limestone, and again in North Wales. In the southeast, where it's dry, you often get it on stone walls, old castles. So Scottish Conference, but those who might know Sussex, you can find it on Amberley Castle. You can find it on bus shelters in a village in East Sussex, in Winchelsea, bizarrely, but otherwise not terribly common. And if you're not sure what you've got, the odds are it's unlikely to be cambricum unless you're in one of those areas. So those are the three species. As I say, diploid, tetraploid, and hexaploid. So just moving on then to sort of the relationships and starting to look at the hybrids. Polypodium vulgare, the tetraploid, which is the species which occurs on acid substrates, is thought to have originated from two North American polypodiums. North America has quite a lot of diploid polypodium species, and Polypodium vulgare is thought, based on isoenzyme analysis and so forth, to have originated as a hybrid from Polypodium sibiricum and Polypodium glycyrrhiza, which then doubled its chromosomes. So Polypodium vulgare is an allotetraploid of that hybrid. There's a degree of speculation in there. I don't think the missing diploid has been identified yet. So it's looking at the isoenzymes and relating them to their parents. Polypodium cambricum then is the other diploid. And in the UK, they all hybridize. Polypodium interjectum, as I mentioned earlier, is originated from the hybrid of Polypodium cambricum and vulgare to form that triploid hybrid, which is Polypodium queeri, which then doubled its chromosomes to form interjectum. So I mentioned earlier that interjectum itself is very variable, and that is part of the reason, because of its hybrid origins in the past. You can find interjectums which look very much like Polypodium vulgare, and interjectums which look very much like Polypodium cambricum. This next slide, I don't forewarn you, I don't think it's going to be terribly clear, but it just sets out the relationships between all the North American species and the European diploid.
So it's from a paper in 1995. I haven't got a pointer, unfortunately. So in the sort of middle left, you can see Polypodium vulgare in there, arising from the hybridization of Sibiricum and Glycyrrhiza. But those North American polypodiums are I find them extremely difficult to identify. There are a mix of tetraploids and diploids, and they are very similar, both in appearance and habitat preferences. So that's the relationship between the species. And looking at it in a little bit more detail, then the three species along the top, and then the three hybrids along the bottom. So Polypodium chivesi has arisen as a result of hybridization between Cambricum and Interjectum to give a tetraploid. Fonqueri is that triploid between Vulgare and Cambricum, and then Mantonii is the hybrid between Vulgare and Interjectum. And if you recall those distribution maps, Vulgare and Interjectum are very abundant throughout the UK, and Mantonii itself is by far the most common hybrid. The least common of the hybrids is probably Fonqueri, because Polypodium cambricum and Polypodium vulgare very rarely overlap in habitats. One's a calcicole, the other's a calcifuge, so you don't often get them growing together, and therefore that hybrid is quite rare. There is a wall, a famous wall, or famous if you're into polypodiums, on Anglesey, where you can find all three species and all three hybrids. It's built of limestone, an old wall running down to Red Dwarf Bay, which is quite interesting. But otherwise, the three species and the three hybrids. So what I'm going to talk about a little bit now is the identification of mainly the hybrids, but a little bit on the species. I get, as referee, I get sent, I haven't counted them up, but I generally get sent about, I don't know, 4 or 5 packets of fronds a year. And most of those fronds are from people wondering whether they found a hybrid. And the hybrids can be quite tricky to tell apart, and you certainly can't tell them apart without looking at the detail of the fertile structures. And sometimes I get immature specimens sent to me, which there's nothing I can do with. So I'll move on a little bit then to identification. So these are the 3 hybrids. They're just there, I grow them in the garden. They're just there to just show what they might look like. Very difficult to tell apart in the field, I find. The books talk about differences in texture and differences in colour. That may give you a clue that you might have a hybrid, but you really do need to look at it very carefully to be sure. So one of the things I often get sent are fronds where the sori are black or undeveloped, and people say to me, is this a hybrid because it is infertile? And the answer to that is probably not, but it is worth a look. There are lots of causes of sterility. Being a hybrid is just one. So these are hybrids, and they look fully fertile. The difference in colour just represents how old they are, because the one on the left is the hybrid with cambricum, so that will be flushing later. So that's a little bit less young, if you like, than the one in the middle, which is one of the vulgare hybrids. So at first sight, those look like fully fertile plants. One clue you might find later in the season is that the Sporangia don't dehiss, so they don't open because they're not functioning properly, obviously. So if you find a plant in the spring
which looks as though none of the sporangia have burst, and I'll come on to what I mean by sporangia, I think, on the next slide, then that may well be a hybrid, but as I say, you do need to have a look. So basic fern anatomy, apologies again if there is an element of sucking eggs in here. So on the left, you have the underside of a frond, and each of those clusters, the cluster itself is a sorus, and each of those clusters contains a number of sporangia. So on the right is a photo of a sorus containing several hundred sporangia, and the spores are inside those sporangia. The brown lines you can see on the sporangia are the indusia cells. So I'll come on to those a little bit later, but basically they act like a hinge so that when those sporangia dry out, the sporangium ruptures and the spores fly out, and that brown streak, if you like, acts as the hinge. So sorus is a group of sporangia. Each sporangium contains the spores, and it is the spores you need to look at really to identify hybrids, certainly. For the species, the number of thickened cells in that indusium is a fairly good and a fairly reliable indicator. Certainly between the differences between the three species, and then Polypodium cambricum also has branched hair-like structures between the sporangium, which I'll come on to later, which is a good spot character. So this is a sporangium which has dehisced, dried out, and it's ruptured. So what you can see there is the open sporangium, the spores have been ejected, and that thick black line on the top left is the annulus consisting of those thickened, those indurated cells. Okay. So sporangia then. Here are a number of sporangia which have opened, dehisced, split, and in the one on the bottom right, you can still see a few spores in there. The spores of Polypodium are light green and kidney shaped if they're good fertile spores, and you can see there the differences between some of those species. So looking at the difference between the first one and the second one, leaving aside which particular species they are, you can see different numbers of indurated cells in that annulus. And when looking at species, and to a lesser degree the hybrids, it is the count of those thickened indurated cells which is really important. My last slide has the table with all the numbers on, so I won't dwell on the numbers here. So good binocular microscope, low power compound microscope is sufficient. You can't see it with a ×20 hand lens. It needs to be a higher magnification than that. I mentioned paraphyses. These are branched hairs which are found within the sorus between the sporangium. And the photo on the left shows one. And really, if you find something like that, as branched as that, sort of a bit like a bunch of flowers or something, that is almost certainly Polypodium cambricum. Once you've seen that, you know you've got Polypodium cambricum, if it's as branched as that. And if you have a good hand lens, you can wrap the pinnule over your finger so the sori are uppermost and spread out, and you can sometimes make out those paraphyses. They look like a little bit of fluff, if you like, between the sporangias. You do need a steady hand and a good ×20 hand lens to spot it, but you can just about do it. but otherwise it's a microscope. If you have branched paraphyses like the ones on the right of that slide, then it's just worth a double check to look at the spores, because sometimes the hybrids of Polypodium cambricum also contain paraphyses, but much less branched. So they can be there, but they are less branched. One of the sort of common questions I get as a referee is, please can you have a look at my frond? I think I found paraphyses here in it, and I'll have a look. And quite often what people are doing when they're scraping off the sorus, the sporangium, to have a look, they're also scraping off some hairs from the underside of the fronds, and those hairs are not branched. So if you have an unbranched hair, that is an unbranched hair, it's not a paraphyses. People are sort of speculating what those paraphyses are for. The best answer is something to aid spore dispersal. I'm not quite sure why or how, but nevertheless, it's a very handy character. So Polypodium cambricum then. Generally, bottom right photo, a fewer number of indurated cells in that annulus. So if you've got, as I say, I've got the numbers on the last slide, but if you've got, I don't know, around 8 or much less, then that is likely to be cambricum. And the photo on the left then shows spores within the sporangia. I think probably at the bottom right of that left-hand photo is a paraphyses. What it's worth noting though is 2 of those sporangia have the typical light green spores, fully fertile, and 2 of them don't. So those sporangia with the white spores in, those are infertile, but because those spores, certainly from this photo, all look regular in shape, that is not a hybrid. So the identification of hybrids is based on spores, but not as to whether the spores themselves are white or green, but really whether the spores are misshapen, either very big or shriveled and just don't look like that typical kidney shape. One of the other characters to help identify the species and then help confirm the hybrids is the number of basal cells. And the basal cells, if you go back to that photo at the bottom right, the basal cells are the number of cells between the stalk of the sporangium and the annulus, the start of the annulus. So on that photo there are 2 basal cells. So you have the dark brown annulus ring, then you have 2 cells before the stalk of the annulus. So again, the basal cells are helpful in helping to separate both the species and the hybrids. And quite often, it's a combination of characters you need to look at. Okay. So spores and hybrids. A number of photos here showing, I will go through these in order. So the first photo, top left, those are all good spores, they're all regular shaped. That is not a hybrid, and that particular one, you can't tell it from the photo, but that is Polypodium interjectum. The second one, again, good spores, all the same shape. You obviously get a little bit of variation in shape depending on how the spores are lying under the cover slip, but basically all that kidney shape, and that again is a good species, that's Polypodium vulgare. The next 2 photos are both hybrids, and they show very clearly a lot of spores which are black or white. They are not regular in shape, and photo 3 right in the middle shows a couple of very big spores, and those are both hybrids. In this case, it's Polypodium Mantonii. 5 and 6, again, good species. Just a bit of a close-up of the spores, showing some of that spore architecture. Polypodium interjectum. And then the last 3 photos, 7 and 8, sorry, show show misshapen spores. 7 is one of those big, large, round spores, and 8 is a shriveled one, misshapen. So if you've got those in quantity, then you're likely to be dealing with a hybrid. And by in quantity, sort of 50% by number, roughly. You will see there are good spores mixed in with these hybrids, or spores which look as if they're good, the normal shape. So it is in quantity a number of misshapen spores. Just get a drink. And just some close-ups now for some of these hybrids. So this is Mantoni. Again, you can see a mix of spores there in that top left photo. Some good spores, or spores which look good, some empty ones, and crucially, misshapen ones. And on the right are those spores still within the sporangia. I think if I saw that, I would immediately be curious, because a lot of empty spores there, and 1 or 2 which look as though they're not the right shape. So I would put those on the slide under a dot of water and just squash the cover slip over. That's sufficient to break the sporangia. Give it a wiggle if necessary, to get some of those spores exposed. And then the bottom left is the annulus ring on the dehissporangium. And again, you can count those cells and count the basal cells. You will have, on the previous slide, no, sorry, on that slide, so picture 7 is a large round spore. You tend not to get those in Polypodium Mantoni. If you've got one of those big round spores, I tend to immediately start thinking about the other 2 hybrids, either Chivesi or Fontquerii. And this is Fontquerii. And in the middle of that photo on the top left, you can see a couple of big round spores, which is a pretty slam dunk hybrid. To determine whether it's Fontquerii, you're into the business of counting indurated cells, counting basal cells, and if it's still not certain, then starting to measure some of the diameters of those cells. On the top right of that slide, you can see a branched Paraphysis. Fontquerii, you'll recall, has one of its parents as Polypodium cambricum, and that is a Paraphysis from the hybrid, really very sparsely branched, if at all. So again, not showing that flowery-like appearance, if you like, of the Paraphysis in pure cambricum, but nevertheless they're indicating it's one of its parents. And the bottom photo there just shows some misshapen spores. Again, so that's what you're looking for. And again, I can't emphasize enough, it is in quantity. It's not just 1 or 2, it is certainly at least half of the spores, sometimes even more, which are not right. This is Chivesi, which is the hybrid between Polypodium cambricum and Polypodium interjectum. Not uncommon where you have both parents growing together, but clearly because Polypodium cambricum itself is restricted, then so too is the hybrid. And again, you can see those big round spores and some shriveled spores. The big black circular things with a white dot in the middle on that photo on the left is my pour technique. Those are air bubbles under the cover slip. But really, I can't, just looking at that slide, I can't see any spores in that slide which look normal. They are all misshapen or oversized. And the other photos show the same. So that is a good Polypodium gervaisii. And this is, I've finished a little bit early, but it looks like there's plenty of questions and chat. So this is a summary of characteristics. And let me just explain those numbers. So Polypodium vulgare, number of indurated cells in the annulus. So the average is 10 to 14, but the range which has been recorded might range from 7 to 17 in any particular one. But really you need to count a sufficient number to get yourself a reliable average. The number of basal cells, you can see 1, occasionally 2, and then no paraphyses. So the difference between those species, really, if you've got paraphyses, it's Cambricum. If you've got a high number of indurated cells, so over 10, it's vulgare, interjectum in between the two. The hybrids, there is, as you would expect, quite a high degree of overlap between those characteristics. I won't read them out, but really they just represent the range of, or the variability of their parents. And again, the paraphyses, they're not always present in the hybrids. They're more often than not present in gervaisii, but less commonly present in Fonquerii. And that, Jim, is me finished. Thank you.
Thank you very much. That was great. We've got a few questions. Let me have a look. So a very general one to start with. How many Polypodium species worldwide? Do you have any handle on that?
I don't. I can just have a quick. No, there are. I don't know. There are probably in North America and Europe. There are 3 or 4 in Europe, and then probably about 10 or so in North America. But there are a number of tropical species. So in terms of temperate, then less than 20 or so, but a number of tropical species. And of course, like a lot of plant genuses, they taxonomically they do get messed about with a little bit. So, but it's not an uncommon genus worldwide.
Yeah. And Fal also asks, is Polypodium cambricum an epiphyte? As an epiphyte, is Polypodium cambricum tree specific, or will it grow on any species of tree?
It is a good question, and I think as an epiphyte, it's probably. Just think it through. I mean, so you find Polypodium cambricum on limestone and limestone walls. It's not uncommon on old castles in its range, or some of those Carboniferous limestone walls. In the New Forest, where perhaps I'm most familiar with it as an epiphyte, it seems to be growing on oak trees, which is unusual, because oak tree bark is not calcareous, and I don't know whether there's any influence of salinity coming in, blowing into the New Forest and making some of those old trees a little bit a lower pH, higher pH, I should say. So I don't know. I think it's so infrequently found as an epiphyte on trees. I wouldn't like to say actually, but given elsewhere it is a strict calcicole, there must be something calciculous about the bark it's growing on, and you might say, well, actually you'd expect it to be epiphytic on ash, and it may well be epiphytic on ash, but not very often.
Great, thank you. Now, this is a good question. What advice would you give to an inexperienced observer encountering a polypody in the field? How do you go? What is the process you go through in identifying them? Assuming you don't just use jizz.
I don't. So let me. So I think the first thing is habitat. So what's it growing on, and where is it? If it's in this sort of, in a limestone area, and the frond shape is fairly deltoid, so quite round with those bottom pinnules sticking back, then I would be thinking Polypodium cambricum. If it's on soil in a hedge bank, then it's more likely to be interjectum. And again, you would look at the fronds. I think it's most first instance, it's about habitat and where it's growing. If the outline is really parallel and it's acidic and epiphytic in, sessile oakwoods, then I think the likelihood is, or my suspicion would be, Polypodium vulgare. But as I say, I've looked a lot of them. There are very few which I would look at the field and say with absolute certainty this is that. If you're in extreme acidic conditions and they're very narrow frond outline, then I'd be confident. If it's on limestone and it's very broad, perhaps with some dentation around the frond outline, I would be thinking cambricum.
So really the take-home message here is you need to get your microscope out and have a look at those annular rings.
Yes, you do. There are certain, if the frond is mature, that annulus ring tends to be a darker brown on Polypodium vulgare. So if you've got one and it's a really brick red dark brown annulus ring which you can see under a hand lens, then again that's pretty good. But actually, if you wanted to be really certain, you are looking at a microscope job and counting. It doesn't take long once you've got your microscope out. And I haven't tried actually, I haven't tried any of these fairly traditional, I think, some old Chinese microscope. I haven't tried any of the new ones which theoretically you can take into the field, these monoculars, to see whether you could do some of that in the field. I suspect you probably could.
I guess so, because you don't need a fantastically powerful microscope.
No, not at all. No, 40 or 50 is sufficient. Maybe 80 if you need to look at the spores and need to start measuring. But yeah. Yeah.
Okay. A question from Anthony Piggott, who asks.
Hello,
he says,
Anthony.
Hello, Rob. Do we know whether the good and the large spores in hybrids are viable as they can be in Geopteris?
I don't know. I'll relay a story, and both parties are now sadly no longer with us. So Dick Roberts, R.H.R. Roberts, who was the vice county recorder, I think, from Anglesey, who published some of the earlier papers on Polypodium and got me interested in it. He always maintained that he had germinated some of those spores from the hybrids. But unfortunately, they were all destroyed by some clear out at the University of Bangor or something. Clive Jermy always rather poo-pooed that and said there are so many spores, you were never going to get them up. I've not tried. I don't think I've got sufficiently sterile techniques in my greenhouse to be absolutely certain. So the answer, Anthony, is I don't know. They may be. And of course, if they are, then it does raise the intriguing possibility of possible back crosses between hybrids, but don't know.
Interesting. John Crossley asks, is it useful to use dye for examining spores? And if so, what would you use?
I don't. I don't know whether it help. I've never found it necessary to. I simply My very amateurish technique is to scrape some of the sporangium off into a drop of water on a slide and put a cover slip on it and just squash it and literally just jiggle it about a bit, and that works for me. So none of the slides I've used have used any dyes in there. If you can angle your light to reflect it sufficiently. So I don't know. I've never tried. I've never felt it necessary. Whether it helped or not, possibly, but it seems not to be needed.
Okay, thanks. Alison Evans comments that Page says that Polypodium cambricum can grow on oak, ash, elder, or hawthorn over base-rich soils and coastal woodlands. So that's going back to that discussion about which trees.
Who am I to argue? It does intrigue me why it grows on oak, because oak generally doesn't have a terribly calciculous bark. You know, ash you can understand. So whether there is something on these old trees which makes them more suitable. And as I say, in the New Forest it grows there. I'm not aware of epiphytic records in the south of England elsewhere, and the New Forest is obviously a very ancient habitat. So
we've got some great questions coming in. Michael, a bit random here, sorry, but here we go. Michael Phillip asks, is altitude an indicator for Polypodium species, or is habitat still the main factor?
That's a really good question, and I don't know the answer to that. I don't think altitude will trump habitat. And I guess where Polypodium cambricum grows, it doesn't grow. Well, I just don't think that there are any particular altitudinal issues. I suspect, thinking about it, there might be. I mean, Polypodium cambricum is pretty hardy, but I'm not sure how hardy it would be in extreme altitudes. As I said, it is a Mediterranean species. I mean, I grow it perfectly well outside in the garden, and it doesn't get burnt or anything by frost. But at high altitudes in the Highlands of Scotland, even if the habitat were right, I'm not sure. But I don't think altitude will trump habitat.
Yeah. Okay. Chris Miles asks, is there any difference in the time of year when spores are produced in the three species, and is this helpful in identification?
Yes, it is. And the spores are all produced in the winter months, or in the autumn and winter. But as I think I said earlier, the Polypodium cambricum, because it's a Mediterranean species, is the latest to flush. So the spores on cambricum and the fronds will be the last of the three species to appear. So again, it's helpful, but of course it does depend on which part of the country you're in as well. So, but if you've got three species growing together and one comes out first and one comes out last, then it'll be Vulgari which is coming out first and Cambricum which is coming out last, in the same habitat, all other things being equal, and then the spores will mature at the same rate.
Okay, thank you. John Faulkner asks, are the dark lines in the annulus party walls between two cells, or are they individual squashed cells?
Let me just share my screen again.
Yeah, go on.
Sorry, I can't get it to play. Right. So what is that going to be the best one? So So what you've got there, if we look at that photo in the top right, you can see a grey oval surrounded by two brown lines. So those brown lines are the party walls. So that grey oval is the cell with a thickened wall around it. So you can just about make out in that top right photo a faint line running, I'm pointing to it, it's not going to work, is it? Running along the middle of that. So in that top right cell, in that top right photo, you are looking at party walls, yes. So each of those grey areas in between is the cell, and that cell has a thickened cell wall, which is showing as brown, and it's that cell wall which holds it together.
Great,
Okay.
thank you. Now, here's a great question from Jan Davidson. She asks, if Polypodium vulgare has North American parents, how did it arrive in the UK?
It is a very good question, and to one which I don't know the answer. There are prevailing westerly winds, of course, and spores are very, very well distributed in the atmosphere, and that I guess must be the answer. There are a number of species, you know, which crop up from time to time, which are North American Adventist, very rarely. That's the only explanation I can think of. Whether that missing diploid has been here a long while and we've lost it, whether we can't separate it out from the tetraploid, I don't know, but it is an intriguing question as to how it got here in the first place.
Yep. The BPS secretary, who's that?
Who's that? Alison will tell you.
Okay. It says, very old bark becomes neutral in pH, as shown by changing lichen community.
Well, there's the answer then. So it is the age of those trees. Thank you. It's the age of those trees, which is allowing a calcareous habitat to develop.
A question from Jonathan Shanklin. How well does the vegetative clue of whether the band between the sinus base and the stem is green or translucent work in distinguishing between vulgare and interjectum? Are you aware of that?
No, just yeah, I wasn't quite.
So I've heard botanists talk about this feature. I wonder if it's actually mentioned in John Pollan's vegetative key. Perhaps somebody could tell me. But so the question is from Jonathan: how well does the vegetative clue of whether the band between the sinus base of the pinna and the stem is green or translucent as a distinguishing feature between vulgare and interjectum?
Yeah, I know what's being referred to. I don't know is the honest answer. I just find Polypodium interjectum so variable. I'm not sure I would really rely on it. I think if I wanted to be sure, I would go to the spores.
Dot Dal asks, is Lismore in Scotland likely to be promising ground for Cambrican? What she doesn't say is Lismore means the Great Garden in Gaelic, and that's a reference to the fact the whole island is underlain by Dalradian limestone. It's a very, very calcareous island. So, and it is near Oban, so about halfway up.
Well, there are Cambrican records from that general area of Scotland. If it's limestone, I would certainly give it a look. Yeah.
Now, I think I might be running out of questions here. I mentioned the vegetative key a second ago, and I suspect you're probably not going to recommend it as a good way to identify polypodiums. Given what was already said about using microscopes to look at fertile material.
I think no, I wouldn't. I would. I was trying to find the quote when I was preparing for this. The Victorians, of course, produced lots and lots of fern books during the Victorian fern craze, and one of them, I can't remember which one it is, and I couldn't find it, has a quote at the front which says, "By their spores shall ye know them," which is a corruption of a biblical quote. And I don't think I would be 100% confident. Now, of course, it depends what your purposes is and how well you need to know, what percentage you need to know, whether you're happy that it was about 80% or something. But I just wouldn't. And I suppose because if you've got vegetative fronds, you are more than likely to have fertile fronds with them. So I would just go straight to the fertile bit, actually.
Yeah.
I'm sure, I'm not suggesting for a minute it's not a helpful characteristic and might help narrow down the choice. It's not one I'd rely on solely myself.
Okay, thank you. So I don't think there are any more questions.
I've just seen Jim Louise has put a comment in which says, in the Veg Key, John Poland himself suggests that people look at Sorian annulus.
Okay. There you go. Fair enough. So this is not a question. This is more an update on a previous question. That was about how many polypodium species there are worldwide. The BPS secretary says the World Plant lists 65 species. PPG1, not quite sure what that stands for, suggests 40 species. And Robin Wall says Martin Richard's new book has 22 in the strictest sense of the genus. It will depend a little bit on which taxonomist you follow, I suspect.
So, yeah, quite. For example, Polypodium macronesicum, Fred Rumsey has elevated it to species status. I've just recently got hold of, it's just published, fantastic book into ferns actually, Remy Pirelli's European ferns, but in here it's a subspecies of Polypodium cambricum. So there is a little bit of taxonomic splitting and lumping going on still.
Rob, that was absolutely brilliant. Really enjoyed that. Thank you for taking time out to put that together. I think the entire audience enjoyed that.